Today we're going to be talking about angles. And an angle is formed when you have two rays that intersect at a vertex. So there's a vertex, and then you have two sides that go on infinitely. And where the word sides is, that's considered the interior of the angle. Now, we can name this angle a couple ways. We can just name it angle B. Another way people sometimes write that is with a little arc in the angle. Okay, so angle B, because there's only one angle B in our picture. We can also name it by the three letters. So one of the letters on the side, A, B, the vertex in the middle, and C, if we wanted. Now, I don't have a number written in there, but if I were to, I can always change a picture by writing in a number. I can also name that angle 1. And again, sometimes I'll write a little arc in there so that we know it's not the less than sign. Okay, again, I want to talk about naming angles, but I want to talk about something a little bit more specific. Angle M. I don't know which angle M that is. That could be the smaller angle, AMH, or HMT, or the whole big angle. So since I have more than one angle that intersects at M, I need to name that. I need to name these angles a few different ways to name the whole big angle. You would name it angle AMT. That's the whole big angle. If you want to talk about the whole big angle. Again, we're never just going to name it by one letter unless there's only one angle in our picture. Now we can also again name the smaller angles. Angle AMH is the same thing as angle 1. And angle HMT is the same thing as angle 2. So again, just different ways to name angles. All right, so now some more definitions. This chapter has a lot of definitions to it. An acute angle is between 0 and 90. A right angle exactly equals 90. An obtuse angle is from 90 to 180. And a straight angle is an angle whose measure equals 180. And again, whenever I do these definitions, please make sure those are in your notes. Our next postulate, the protractor postulate, very similar to a ruler postulate, just in terms of a protractor now. So when you're given on AB in a given plane, so let me explain what that means. When you're given a line, AB, in a plane, choose any point O between A and B. Consider OA and OB to be all rays that can be drawn from O on one side of AB. These rays can be paired with real numbers from 180. So I can draw a ray there, let's call it OC, and OD, where, let's say AO is 0, and then I rotate up to angle D, which is going to be a certain number. Or we could change OB to be 0 and rotate up to a certain number. So if OA is paired with 0, OB would be 180. And then there's another one. If OP is paired with X, let's adjust our letters here a little bit, since I talked about OP and OX, or OQ. So this is the value of X on our protractor. This is the value of Y on our protractor. We can find this angle measure by subtracting X from Y or Y from X and taking the absolute value, just as we did on a number line. Adjacent angles, this is going to be very, very important to us. Two angles in a plane that have a common vertex. So here I have a common vertex and a common side but no common interior points. Angle 1's interior points are in there. Angle 2's interior points are in there. Now 3 and 4. Think for a minute why those would be not considered adjacent angles. Think about the first part. They have a common vertex. That's the vertex for 3. That's the vertex for 4. They do not share a common vertex. Angle addition postulate, or I didn't put our abbreviation in there. Again, if I don't give you guys an abbreviation, just remind me during class. AAP. Angle addition postulate. There's 2 parts. And again, just as with segment addition postulate, we're going to be using this in our proofs. And angle addition postulate has 2 parts, so we're going to be using this, both of these reasons, as reasons in our proofs. So if a point B is in the interior of a big angle, so B is in the interior, then angle AOB plus angle BOC equals our big angle. Now there's another part where you have, if AOC is a straight angle, or OA and OC are opposite rays, and B is any point not on our angle, then AOB and BOC equal 180. So if you have a straight angle or a line, this angle plus this angle is going to be 180. And that's going to come up a lot in proofs, so please make sure you guys take note of that. Okay, first example. The measure of angle AOD, and I'm going to label my diagram. It's important that you label your diagrams. 4y minus 8. DOC, I'm going to draw a little arrow to it, is y minus 11. And COB is y plus 13. Find the measure of AOD. Well, angle AOB is a straight angle. So I know that 4y minus 8 plus y minus 11 plus y plus 13 equals 180. Now combine like terms. I have 4y, y, and y. That's 6y. I have a negative 8 and negative 11 plus a 13. That's going to be a minus 6 equals 180. 6y equals 186. When I divide by 6, I get 31. Now again, remember my high school geometry teacher. He stressed this to me, and I still remember it to this day. Make sure you're answering the question. Find the measure of AOD. Well, AOD, that measure is 4y minus 8. So I need to plug in 31 for y. 4 times 31 minus 8 is 116. Next, a bisector of an angle. We're going to be using this definition a lot. It's a ray that divides an angle into 2 congruent adjacent angles. So I have 2 congruent. How we mark congruent angles is with arcs. Say that is congruent to that. You mark it with 1 arc. Say in your picture you already had something marked with 1 arc. So you just can do 2 arcs then. So that I know that angle XOY would be congruent to angle ZOY. Another way, I just want to make sure you guys see this because sometimes I'll do this. Another way to mark congruence in angles is if you draw an arc. And kind of like what we did with segments, put a little dash in them. Sometimes I'll do that if our picture gets really busy. Okay, so BX bisects ABC, solve for X. So let me draw a picture, ABC. I have angle A, B, C. Make sure you guys are drawing pictures. That's the first thing I'm always going to ask you guys. And then I have BX bisecting it. I have the whole angle is 4x minus 12, and ABX is 24. So ABX is 24. Since we know BX bisects, I know this angle is congruent to that angle. So I know this one's 24. So I now know that 4x minus 12 is equal to 2 times 24, or 4x minus 12 is equal to 48. So now what we do is we solve for x. So I get 4x is equal 60. Divide by 4. I get x to be 15. Now geometry, the most important part of geometry is pictures. You cannot imply anything from a picture until it has markings on it. So right now I can't tell anything from a picture. Once I have some markings on it, now you're going to be able to tell me a few things. And I've already started talking about some of the markings. Because AB and BE are both marked with 1. AB is going to be congruent to BE. Now, since BC and BD are marked with 2, those are the set that are congruent. So BD is congruent to BC. All right. Now, we talked about our angle markings. Since angle ABD is marked with 1 arc, and DBE is marked with 1 arc, those are congruent. And then there's one other thing. This little corner means that angle EBC is a right angle. So whenever you see those markings, whenever you see that right angle, that little corner, that means that that angle is a right angle. So these are the 4 things that we can tell. You can't tell anything without any markings. So don't imply anything from your pictures. There are your lesson questions for the day. Both of these questions here refer to the picture below. So this is for the picture below. And please make sure those are submitted on time.